Okay, so this video tutorial, oh, by the way, welcome. This video tutorial is going to be projectile motion. So what we're going to do is we're going to start with motion in, let's say, the horizontal direction. So an example of this is you've got a table and a ball rolls straight off and lands. Okay, now it's not going to look quite like that, but what's going to happen is you have an initial velocity, okay, and it is going to be straight in the x direction, okay, because imagine you have a coordinate system set up, and straight to the right is your x, and straight up and down is your y. So this ball's initial velocity is straight right. In other words, v initial is only has an x component. And let's say it rolls off going, let's just say 2 meters per second. Well, that initial speed, okay, is your vx, because how to go about these problems, or what you're going to have to do, is you're going to have to think about components of this vector in terms of its x and its y. Okay? In this case, our component is only in the x direction. So, if you imagine your angle is 0 degrees, well, to get the x component, in this case, you would do v naught cosine of 0 degrees, which is just v naught, or your v initial. Now, let's say that you roll the ball off and you want to know how long it's going to take before it hits the ground. And let's say this table is, let's just say 4 meters in the air. Okay? And so you want to know the hang time of your ball. Well, to go about that, you're going to have to know how long it's going to take to fall. Falling involves the y direction. Okay? So our vy, in this case, our v initial y, is 0. Well, to do this, we use the kinematic equation, delta y equals our v initial y times our time plus 1/2 at squared. Now we're assuming that this table is on Earth, and in this case our v naught y cancels out, so we're left with our delta y. Now our y initial is going to be 4. Our y final is going to be 0, because the ground, I would make the ground 0. So delta y in this case is going to be -4. And that equals 1/2 times -9.8, and again t squared. And so what you can do is just solve for t, and that would give you your time it takes for the ball, or whatever we're rolling, to hit the ground. So we've got -4 divided by -4.9, and that gives me a time of 0.8 seconds. Now, say I wanted to know how far the ball rolled away from the table. What I would do is I would make its leaving point from the table the origin, or 0. And despite what Archimedes wants you to believe, there is no acceleration in the x direction, as long as we neglect air resistance. So, our AY is -9.8, and then our AX is going to be 0. Well, in that case, we can just use distance equals velocity times time. I now know my time, and I know my initial velocity in the x direction. Well, that's 2 meters per second. So that would give me 2 times 0.8, which gives me a distance of 1.6 meters away from the table. So horizontal velocity problems are great because you don't have to deal so much with components or an angle of initial velocity and stuff like that. Now, another type of problem would be if you have a ball that is thrown straight up. Okay? Again, this is just, say we've got a ball. Oh, wait a minute. I know what I can show you. Let's look at, hey, looky there. We don't need that. So, here Dortch is throwing up a ball, and he's throwing it pretty straight up into the air. Okay? And so, a very crucial aspect of this is the graph of your y position versus time. If you notice, this is a very nice parabola. Now, I didn't scale this right, and so I've got 1 Dortch here. And so if I analyze that, and I fit it with a parabola, it gives me a really nice equation. That parabolic shape is always describes your y motion when it comes to projectile motion problems. It'll always follow this parabolic path when it's your y position versus time. Now, let's look at our x position versus time. Analyze. And as you can see, it stays pretty close to the origin that I've made it. Okay? So, in other words, our x position, here I can change the origin real quick, that might make it a little bit easier to see. Analyze. Nope, still not that easy. So your x position stays linear. That is because there is no acceleration in the x direction. In other words, your x has constant velocity, whereas your y changes.